let's talk about our sun. Our sun is the nearest star, and it gives off the light and the heat that we need to survive. The sun isn't too close or too far to support life on Earth. At an average of 93 million miles away, that's a long way. Even though the sun is that far away, it only takes 8 minutes for the light from the sun to reach us. The sun is about 10,000 degrees Fahrenheit, and that's really, really hot. And it gives off light and other waves that make life possible. Today we're going to talk about the sun and some of those waves that it gives off. So the first thing, how do we see the sun? Well, we know that the sun is up in the sky, but it's very, very bad for our eyes to look right at the sun. So what we can do is that's why we have special glasses for solar eclipses. Have you seen those? The little paper glasses, and they block out the harmful rays of the sun so that you can look directly at it. But normally we can't look at the sun because it's really bad for our eyes. So we can observe it in other ways. So the first way we're going to talk about observing the sun is something called a pinhole projector. And it's a super simple little device that you can make. It just has three things that you need. You need an index card or some cardstock. You need a thumbtack or a needle, and you need another plain piece of paper. Okay? So what you're going to do is you're going to take your index card and your tack, and you're going to poke a hole into the index card. Okay? So now there's a nice little hole in my card. And what you're going to do is you're going to hold that up to the sun with the paper underneath, and the little itty bitty circle that forms on the paper beneath it, that's actually an image of the sun. It might look like a shadow, but it's not. It's an image of the sun. Pretty cool. You can also do this with the leaves between trees, or a colander. Some colanders will do that, like what you use with your pasta. That's why, since it's an image of the sun, if you did that during like a solar eclipse, like there's going to be one in a few years here in Utah, and that's why it shows up as like little crescents in between the leaves. That's because it's an image of the sun, and that's what the sun looks like. So we can also learn about the waves that the sun gives off, and some of those waves are the visible light. So if we look up at the sun and we look all around us, there's white light, right? So white light is actually made of all of the colors of light. So we have some super cool glasses. They're called diffraction glasses, and I'm going to show you what those, how those work. And what they do is they take the visible light and they break it up into all of the components. So what do you guys think that you see if I broke up all the white light into all of its components? Yeah, so we would see a rainbow. So we're going to see the diffraction glasses. Diffraction glasses, like these, are a way for us to see light in all of the different visible wavelengths. So what these do is they come up and you look through them, and it splits the white light into all of its components, which is the rainbow. We can also observe invisible light in different ways. So we can't see the invisible light like UV rays, but we have some pretty cool ways that we can. One way is UV beads, and what those do is they have a chemical change that happens when they're exposed to UV light, like the sun, and they change, well, I'll let you see what happens. Here in my hand I have some UV beads, and they react to the ultraviolet light that's put out by the sun. So let's open the hand and see what happens. See, they start as white, and now they've turned different colors. There are many other kinds of waves that come from the sun, like infrared and gamma rays, and explore the electromagnetic spectrum to learn more about all of the cool waves and other good stuff that comes from our sun.